Cool. Okay. Well, I've been told to be on time, so I'm going to try and go as quick as I can. So I'm going to talk about how we built a real-time data pipeline using serverless and Kinesis. I'm going to go pretty quick. So first off, who am I? I'm the CTO of busuu. We're the world's largest social network for language learning. So if you want to learn French, German, Chinese, Japanese languages, that's what we do. And tech.busuu.com is us. Before that, I was at Just Eat, so I was the head of technology for Just Eat in the UK. And before that, I was at a company called Serverless, who some of you might know. I think they're a competitor of one of our sponsors. And so they do server monitoring and alerting with target to DevOps market. I'm CEO of a thing called AltConf, which is the world's largest Apple developer conference, which may not be super interesting to all of you, but I like to say world's largest for things. So I like to drop that in. And then before that, I was an engineer. So I was a PHP engineer, I was a DevOps engineer, I was a mobile engineer, hence the iOS bit. So that's who I am. So I'm going to talk about us building a real-time data pipeline. So what was our problem? So we have a huge amount of users constantly doing things. So we have 70 million users, and they're constantly learning. So they're learning a new language all the time. They're interacting with each other because it's a social network. So they're always doing things. And all of our company wants to know the things that they're doing so that we can help them do those things better, or sell things to them, or generally make their lives a little bit easier whenever they're learning. Over time, our events tracking had kind of gone in a very disparate way. So we had lots and lots of different providers for events tracking, and we wanted to bring that together into one single source of truth. And we were using lots and lots of third parties. It was really slow to understand all of our data. So lots and lots of third parties means that they have, an hour they'll turn around data and we can use it, or it'll be a day, or it'll be a week. Maybe not a week, but there was lots and lots of different data sources. So it was really slow to understand user behavior and pull all of that data together. It was really slow for us to fix things. So we have mobile apps, we have a website that all the trackers were in, and we'll talk about what the trackers were in a minute. But it's really slow to update apps to fix trackers. And so we wanted one place where we can be super flexible with it. And of course, there wasn't nearly enough shiny things. So we have lots of shiny things, but we want to have more shiny things. So we wanted to make more shiny. So some of the integrations with third parties that we had, so some of these may or may not be familiar to you, but just to give you a sense of the scale. So Intercom is a product management tool for talking directly to customers. So our product managers can get kind of quantifiable feedback on our product. AppBoy is a product that's used by our marketing team to send out emails, send out push notifications about campaigns, about just lifecycle emails. You've been learning this language, here's what you've learned this week, so on. Adjust is a tool that's used by our marketing team to attribute PPC, so pay-per-click, and where users have actually come from, so we know how good our marketing campaigns are. Amplitude is used by our product team to understand all of our data and to look at graphs and charts and understand the flow of users through the platform. Optimize and Optimizely is used for A/B testing, so we A/B test a lot of stuff, so our product managers and our data team will use that. Oracle is what we call our internal machine learning framework, and we use that to give us real-time kind of predictions on what people are going to do. Are they going to churn? Are they going to convert? Stuff like that. Plus lots and lots more. So this is just an example of just how many tools that we're using. So what was our solution? Well, we wanted to be real time. If we're going to rebuild something, and given this was a massive mess, we decided just to rebuild it. We want it to be real time, or as real time as possible. We want it to be scalable. So we have 70 million users. We're going to have 80 million next year. We're constantly growing, so we don't really want to worry about the scale of it. We want it to be flexible, so we want to add third parties as easily as possible, because tomorrow our marketing team could come along and say, we need this tool, we want all of our data in this tool so that we can make the most of it, and we don't really want to have to wait 2 weeks to update our apps to do that. Our data science team spend a huge amount of time cleaning data, and we want to try and do that as early as possible. And we wanted to go serverless because we want to reduce the amount of DevOps load and costs that we have. So what's our solution? Well, let's look at it from the perspective of a user. If I'm Rob and I'm learning French, and I just learned the word bonjour, what happens there? So that's me, or a bunch of me's. And I just learned a word and I got it right or wrong in an exercise. So yes or no, I got it right or wrong. Then that'll send an event to a load balancer. And that load balancer sits in front of multiple machines, which are all running a thing called Snowplow. I don't know if anyone's heard of Snowplow before, but it's an open source tool. It's run by a company here in London. But in its very essence, it's about data ingestion and data enriching. So what we do here is a JSON event comes in. It gets sent to one of these servers. And those servers take that event, and immediately they throw it into a Kinesis queue. And why do we do that? Well, we want to get back to the app as quickly as possible. The app doesn't care that it's going to take us 5 minutes to do all these things with the data. All it's doing is sending us like lots and lots of events all the time. And so it doesn't really want to wait. So we put the events into this queue. And then we return to the app and say, you're all good, continue with your day. Then after that, we use Snowplow again, so completely separate set of Snowplow servers. So this one here literally just takes the data and puts it in the queue. What this one does is it enriches the data. So it takes the IP address that it came from as an example and converts that into a country. Or it takes the user ID and goes to our user database and says, okay, well, that's all the user information, and enriches with a bunch of user information. And a lot of stuff on top of that, but that's effectively what it does. What does it do with that? Well, it puts it in another queue, because why not? Just queues on queues. So this is a bigger queue, and I'll explain why in a bit, but we put it into this queue. So this is our enriched queue. So this is our raw data queue, and then our enriched data queue. And then from our enriched data queue, we have a bunch of Lambda functions. And so our Lambda functions do a lot of different things. They talk to all of the third parties that I talked about before. So we just ping events off to lots of different third parties, and this gives us the scalability and the ease that we really wanted, because our apps are just sending different bits of data or different events that we care about, and then we can route those events where we want them to go. We also send it to Redshift and to S3. So for our data team to actually process things in Redshift and give us some answers, that's what they use. We send it to S3 so we don't lose it. So if we ever need to replay it, then we can have it in there. We also send it to our machine learning. So oracle.busuu.com is our machine learning platform, which means that we can ask questions. Is this person going to churn? We get a reasonably quick answer. Things go through this pipeline in less than 30 seconds. So we get a pretty quick answer. And then, of course, this has an API in front of it, or a load balancer API that all of our clients can use whenever they want. Either our APIs themselves are using it, or clients are using it directly. Whoever wants to use it, they can use it. So let's take a look at some stats. This is a chart over the course of a day. Obviously, we have peak times and not peak times. I mean, we're a worldwide business, but still, you can see we're big in America. We're big in South America as well. So we have more towards the end of our day, and then it kind of flattens out and it kind of cyclical. So this is records every 5 minutes. What you'll see here, the orange line is our raw data and the blue line is our enriched data. Why is that? Well, all of our raw data, all of our clients package up lots and lots of events into one call, and then we send that to our API. And then that gets put in our raw data. And then whenever it gets enriched, we pull all of those events out and then enrich all of the events individually and put them into the enriched queue, which is why the enriched queue is double the size of the raw queue. Yeah. Some more stats. We do about 6,500 to 7,000 raw events a minute, 15,000 events a minute in our enriched queue. This was just at a random time that I pulled. I don't know what time I pulled this off at, but yeah. In terms of actual amounts of data, we do about 25 to 30 meg a minute of data through the queues. And again, just remember this is Kinesis, so it's completely managed. So we don't really have to touch this. We just set it up and it just runs and super easy. This is how much it costs us every month. In case you're interested. So we do a lot of Lambda invocations, but the Kinesis stuff is pretty cheap. The reason that that's so high is because we did something stupid last month, and so it's a little bit higher than it should be. We'll not talk about that. So how does Snowplow work? It's open source and Java-based. It's a schema-based validation. So it validates and it enriches data on the way in, as I said. And you can have it enrich data in real time if you want. We chose not to do that. We use Git to store our JSON schemas, but they're all JSON-based. And here's an example of Git, and we have lots and lots of different schemas. So we have a standard schema for progress events, so how someone's progressing through a course. We have a schema for that. We have user registrations, profile changes. If someone updates their profile or changes something that's on their profile, then we want to know about that for various different campaigns or to whenever we're talking to them in intercom. Here's a screenshot of one of our schemas, and you can see it's pretty standard, but you can see things like the type of event, the user ID, timestamps, interface languages, platform, so iOS, Android, web, app ID, so which version of the app are we using. We have multiple different versions of the app for different reasons. So that's that. And then one thing to think about is whenever we were serving these up, the recommendation from Snowplow is to serve these schemas off of S3. Given the amount of traffic that we're doing, we tried to serve them off S3. S3 is not very good at that because Snowplow will ask for the schema every time it wants to use the schema because apparently it doesn't cache things. Or we were using it wrong, I don't know which, but we couldn't even get close to real time whenever we were serving it off S3, so we just serve it off of Nginx on the box, which is fun. So what is this pipeline process? Progress events, so how far you are through a course, what you're doing on the course. It processes user events, so did the user click on something? Did the user view something? That's useful for A/B tests. That's useful for our product team to understand how things are happening. Marketing acquisition data, placement test results. So whenever you join the platform, you can do a placement test to see how good you are at a particular language. And that's useful for us to know because then we can know how well you're progressing over time. Processes callbacks as well from different platforms. So platforms that are third parties will give us callbacks like Apple and Google and other places. And it processes user properties. How does our Lambda work? It processes in batches, so it pulls off of the Kinesis queue in batches of probably, I think, about 100 at a time. So Lambda will maintain the trim position, so it will maintain the last thing that it saw on the queue. So if it gets backed up, it will just process through in real time as much as it can. The majority of our function sizes are between 128 meg and 386 meg. I don't know if anyone has ever used Lambda too much, but the function sizes have a direct impact on so this is the RAM, but then it has direct impact on the amount of CPU and the amount of network throughput that you have. So for the majority, we keep it in this and you pay more depending on the function sizes that you use. For our main Snowplow processing, so this is the Lambda that pulls from the enriched queue and puts it into Redshift and puts it into S3. We use the maximum size, and also for whenever we're sending it to Amplitude, because that function basically takes every single event that comes through and doesn't throw away any events. It cares about everything and tries to save everything. So it needs the maximum amount of network throughput, not necessarily CPU or RAM, but we couldn't. You can't decide how much network throughput you have. You just have to say, I need this much network throughput, so therefore I have to pay for the whole thing. So it's not really as fine-grained as, say, using EC2. Let's look at some more graphs. This is our Lambda processing. So this is a really good example of how easy it is for us to split up different providers that we're talking to. So you can see we've got Amplitude, Snowplow, Appboy, Intercom, user details, adjust, lots and lots of different things. So you can see that some Lambda functions care about some events, some care about all of the events. So that's interesting. What we really like about this solution as well as it being super flexible and we can just add in another third party here is that it's also scalable. So this is the oopsie that we made where there's no count on the. Sorry, I should have put a y-axis on, but this is 10 times higher than the previous graph. So it just deals with it and doesn't really like care too much. Obviously, the bill cares, but Kinesis doesn't really care. It will just scale it out. And we'll talk about shards and stuff in Kinesis in a minute. And actually, Kinesis is the cheapest bit of this anyway, so putting a lot of data in there doesn't really matter. So this is the triggers, how to add a trigger. I just wanted to point this out because we use the trim horizon, but if you ever have any problems or something stops working, you can just start a new Kinesis invocation at a timestamp and process everything back from a certain time onwards, which is super handy if you ever have any problems. There's lots of trigger options. You can trigger off of most things in AWS yeah. API gateway is basically just an API, so you can trigger basically off of anything. How does Kinesis work? It stores data for 24 hours by default. We don't use that though. We go for 4 days. You have to pay more for that, but it means that if we ever have a problem over the weekend, we don't have to worry about it because the data is just there, and then we just start processing it again. We don't have problems because it all just works. But I say that, but Stefan, our DevOps in the back there is cringing because something will happen tonight, for sure. Sorry? Oh, shit. Okay. All right. Well, we're going to have a conversation later. So this is all our Kinesis. Well, this is a subset of our Kinesis streams, just to show you the different number of shards. So our enriched data and our raw data are 12 and 15 shards, and then we've got some integration and test ones there, which we just have small numbers of shards on. Cool. Evolution of our deployment. So we deploy Snowplow through Terraform and Puppet, but we were doing manual Lambda deployments. We're migrating to serverless frameworks, and I'm going to talk about that in a little second. And eventually, we're going to start doing stream processing with this same thing. So we can do stream processing straight off of the Kinesis queue for our machine learning and data aggregation. So we're pretty well set up to start doing that whenever we want. It's almost stream processing right now, just because of the way that Lambda works, and it'll just pull off of the queue and start processing stuff, but there's more that we can do there. So in terms of serverless frameworks and deployments, I'm sure you all know that there are 3 big serverless frameworks. There's serverless, there's Apex, and there's AWS SAM. We use a subset of 2 of them. So we were doing dangerous manual deployments where we're just zipping things up and just sending it up to Lambda, which wasn't great. Our aim is to put some automation around deployments, but not all automation. Frameworks that we've learned tend to really like having super user privileges. So you can deploy things straight from your command line, and that's great. But you don't want to do that because they have the ability to create IAM roles and basically do whatever the hell they feel like, which we didn't really love. And doesn't really work once you have more than one person deploying these things anyway. So what our plan is, or what we're currently working on, is using serverless to package a zip file and then deploy that through automation. We use Samson for all of our deployments across all of our APIs and our front end. And so we're going to use Samson the same. Samson is just a web GUI on top of Capistrano and other scripts that you can run behind it. So our plan, well, what we are actively working on right now is using Samson to run the serverless scripts that will package up a zip file, and then that process will then upload it to Lambda via AWS APIs. But for local testing, we're using SAM Local. So that's a plugin and an add-on for SAM that you can get. And in a nice and very convoluted way, serverless will convert itself to SAM, and then we can use SAM with SAM Local to test things locally. But it doesn't completely replicate the AWS environment because you don't get Kinesis queues and you don't get all the other like fancy things that they have. So you kind of have to semi-replicate it. Cool. That's it.